But what about like meal timing? If you do lift and your protein synthesis remains elevated for like the coming few days, then how would you have to implement like the protein intake within that time frame?
Yeah, that's a good question. There's a few studies that have sort of looked at this question, a few that have directly looked at it. And it's interesting that we have research showing that the anabolic window, the period of muscle protein synthesis increase post-training, decreases as you get more advanced. We also have a study showing that in untrained individuals, actually compared to bodybuilders, was Nori et al. From Japan, they found that the protein timing doesn't matter at all in untrained individuals, probably because that stimulus is going to be around for days. So you know, if you have your post-workout shake immediately after the workout or 4 hours later, it doesn't matter. It's like all within the same time frame, physiologically speaking. But for the bodybuilders, it actually came to a few hours. There's a few other indications as well that suggest to me that you want to sort of mimic this curve of protein synthesis. Basically, you have to fuel the anabolic window. So the anabolic window it's an anabolic window of potential, researchers sometimes call it. It doesn't mean you actually get that protein synthesis. You do have to fuel it. So I like to basically give more protein in the periods after workouts, and especially the period between the workout and the evening. There's a few studies that have looked at this. If you wake up, you have to work out, and you go to bed, and if you have most of the calories here, that gives poorer results in a few studies than if you shift the calories to post-workout in between the period of workout and bedtime. So yeah, I'm a big fan of doing that and basically trying to synchronize calories and protein with the anabolic window.
Yeah, and it's super. I also like to think that, you know, using protein for recovery and repair is probably much more important than taking it before you have stimulated the muscle. So yeah, let's say that goes back to the idea that you can build muscle and lose fat at a deficit if you strategically time your protein more carefully after the workout.
Yeah.
So yeah,
exactly.
That's interesting. But how would it change in some people who are doing the like intermittent fasting for like 16 or 20 hours a day or something like
that? It could still work. I don't think fasted training is going to be optimal. There's actually a recent study reviewed on Facebook about this. A pretty crappy study because it only had like 5 subjects, but it strongly suggested at least that it was between a group training completely fasted and not having anything post-workout either, a group having just post-workout protein, and a group having pre-workout protein. The group with the pre-workout protein actually had the best training volume, the highest training volume, and the best muscle growth and strength development over time. And that's, I think, makes a lot of sense. Ideally, of course, you want both. It doesn't have to be super immediate, but you do want to sort of sandwich your workout between 2 meals. Doesn't mean running down to the locker room, slamming down a protein shake. It just means you want those amino acids in the blood. And if you have like a whole meal, like steak or something, then those amino acids are going to be around for at least 6 hours generally. So no immediate rush, but you don't want to fuel that period. And you want to make sure that as soon as you are exercising, you want hyperaminoacidemia, so elevation of amino acids in the blood. So the mTOR you referred to earlier, it registers that signal. It basically integrates all the signals for muscle growth, like do we have amino acids? Do we have tension on the muscle fibers? Are growth factors active? Is this guy on gear? And it integrates all of that and sends it down to the nuclei, the cell cores, or DNA. And there basically you have the blueprint to form your whole body. And that information is transcribed to the ribosomes. It's like you have the blueprint, it's translated and transcribed, goes to the ribosomes, and those are like the factories that create new proteins. Those make the proteins as per the blueprint. And that is the actual process of muscle growth and muscle protein synthesis. And that adds to the contractile tissue in the muscle. So you get bigger muscles. So it makes a lot of sense that having all these sensors for mTOR in place, so that mTOR senses, you know, we have the stimulus and we have the means to build muscle, that it's all in place.
Yeah, I agree as well. Like it is probably a better idea to have some amino acids in the blood before you train, just to protect against potential muscle catabolism and gluconeogenesis and things like that.
Many people in research, if you put them on a keto diet, they'll start losing fat even if you try to make them gain weight. Or 75% of glycogen was resynthesized within 6 hours after a strength training workout, and that's fasted. That's without
No,
any dietary intake, exactly. The training volumes actually needed to make those carbohydrates necessary. You do not encounter those for strength training. Your body has the building blocks. If you give it protein and it can take the fat, it can build muscle mass as long as the training program and everything is stimulating that process. If you're talking about an obese individual, they need to lose fat yesterday. So anything you do that gets them to lose fat will improve their health. Many people have this idea that dieting is unhealthy or whatnot. Any biomarker you look at will improve with fat loss.
Body-mind empowerment.
Get stronger, faster, smarter, quicker, friendlier, more helpful, more driven.
Everything the body needs.
Control your mind.